Good morning, everybody. This video is going to be about how to index on high torque mini lathe, little machine shop mini lathe. And the indexing will be done from the back end of the machine, the gear end, where all the thread cutting gears are. And it actually utilizes some of the gears to maintain the index. These are some of the parts that you need to lock the spindle, and what they consist of are a machined mandrel that inserts into the back of the spindle, and it's machined out of aluminum. It's about 2.5 inches long, and it's got a 1/2 inch hole bored through, and then about an 18-degree taper machined from the back end. This is a 1/2 inch bolt where the head's been shaved down, also machined on the same angle. You can see the slight taper there. That fits inside of the mandrel section, which has been slotted to allow for the expansion once it's inside of the spindle. Then there's a washer as a spacer. There's a bushing, which is 1/2 inch ID, 5/8 OD. The 5/8 OD being the same as the gears, the thread cutting gears that come with the lathe. So basically, put the washer on, you would put the required gear on here, which I'll explain in a minute, with the bushing, and then lock it up with the lock nut. The lock nut does two things. Number one, it locks the gear that you're going to install here to the mandrel, and it also draws the bolt up inside of the mandrel and locks it to the spindle. So once you have that done, the other parts you're going to need to machine are an arm like this, and this is a piece of 1/4 by 3/4 steel. I think it's about 3.5 inches long. Yep. It's got a 1/2 hole cut in the one end to hold the actual indexing gear. And again, you have a washer, a bushing for the gear. That gets threaded on here and locked tight so that the gear will not rotate. There's a small hole here for a tensioning spring, and the back hole is a 3/8 hole, which is the pivot that the arm actually rotates on. Okay, here we are over at the back end of the lathe, and you can see the spindle and the normal gear set there. And the first thing we want to do is take the mandrel and install a gear on the mandrel. You can see the spacer in there and the bushing and the nut. You want to use a gear here that is some multiple of the way you want to divide on the spindle head. In this case, this is a 50-tooth gear, and I chose this one because I actually used it to engrave a micrometer wheel for my bench stop. That allows me to advance in thousandths of an inch. So with a 50-tooth gear, you could obviously do 25 spaces, you could do 50 spaces, you could do 5 or 10. And if you use, say, a 30-tooth gear in there, you could do 3 spaces, you could do 6 spaces, 5 spaces, 15 spaces. And depending upon what gear you choose is the way you'll be able to divide on the head. So this assembly gets pushed into the back of the spindle, and once it's in there, you draw up the nut to tighten it in the spindle, and basically lock it to the spindle and lock the gear so it won't rotate on the shaft. Let me give it a little bit of a tighten here. Okay, now once we've done that, you can see there's a standoff here where one of the mounting bolts was for the door frame. And I've machined a standoff that allows me to install the pivot bracket such that it will line up with the gear that's on the mandrel. And I'm going to put that on and then come back. Hold on. Okay, you can see I've installed the arm, and the gear is on the arm. Now that particular gear, that's not critical at all. I just use the smallest gear that I have. In this case, I think it's a 30 tooth. And the spring applies downward tension to hold the teeth engaged when you're doing the operation on the spindle end. And you can see I've got the 50 tooth gear marked in 5 tooth increments, and actually I've got a long space and then shorter spaces in between. This would be the 10 point, this is the 5 point, and of course each one of the individual teeth is a single point of rotation. The spring is attached to just a little bracket on the lower bolt there, and that's there just to apply some downward pressure to keep them engaged. Now you can rotate this with this spring because it's really not strong enough to totally pull it down, but for most operations on the turning end of the lathe, there's enough tension there to keep the spindle from rotating. If you want to advance forward, you'll see that the tooth will slip over. I've gone 5 teeth there, so if I was doing say 10 spaces around the piece I'm working on, I would just advance it 5 teeth each time. And otherwise you can just lift it by hand and turn the spindle for the next operation. So that's basically it. It's not too difficult to fabricate the parts. Like I said, they're you know, with most of the gears that come with the gear set, you could obtain pretty much any hole space pattern or drill pattern you wanted. Now if you get into gears much larger than 50 teeth, you can see there would be some interference down here, but up to about 70 teeth, you know, you can get most normal combinations of patterns for indexing. Okay, I hope that helps. Good luck, everybody.